Welcome to Behind the Binary, the podcast that introduces you to the fascinating people, technology, and tools driving the world of reverse engineering. I'm your host, Josh Stroschein, a reverse engineer at the Flare team at Google. In this episode, we have a fascinating conversation with Jordan Wiens, developer of the widely used binary Ninja and co-founder of Vector35. Jordan brings his expertise as an avid CTF player to a discussion about the complexities of building a commercial reverse engineering platform, the importance of community growth, and the significant future role of AI. We also delve into the unique nature of having active adversaries inherent in cybersecurity work. Get ready for an insightful conversation that will shed light on the hidden layers of technology and take you into the world of reverse engineering. Joining me today is Jordan of Binary Ninja. Jordan, thanks for taking time to join the podcast today. It's great that you're here. I think we've crossed paths many years ago now. I was just looking up a little history on Binary Ninja. It was actually really close to when you launched the product, it looks like. So
it was.
So yeah, really awesome to finally get a chance to sit down and chat with you.
Yeah, thank you for having me, Josh. I appreciate it.
Yeah. So can you maybe tell us a little bit more about your background? It looks like, you know, the main focus today of our conversation will be around Binary Ninja, but you know, like who were you before Binary Ninja? It looks like there was it was developed out of some internal tooling. I know you're very active in the CTF community.
Yeah.
You know, so what is the history there for you?
Yeah, so there's sort of the two parts. There's my personal history, and then there's the history that led into Binary Ninja. And the personal history started kind of at the University of Florida. I was a network security engineer, so I did like forensics and incident response, and started doing a lot of like network defense type things. And it was interesting being there, watching like the style of what that industry looks like. Like EDR wasn't really a thing by that name, and the sort of idea of like, let's log everything, let's log all that hashes, all the traffic, and then correlate and look through logs, and it was kind of just starting, which is super fun and interesting. But I started playing capture the flag, kind of like this offensive security stuff, and was like, this hacking stuff is neat. I've always wanted to do that. And so I actually met somebody at a SANS conference who went on to play DEF CON CTF, and I was like, dude, you were not good enough. What happened? He's like, well, I've been practicing the way of the ninja. I went and got a mentor, and I've been working on it, and been studying writing exploits and doing reverse engineering. And I was like, okay, I got to get into that. And so that turned into like starting to play capture the flag, starting to get into kind of offensive security, and then that turned into a 7 or 8 years of working for a defense contractor, doing full-time vulnerability research, and writing exploits, so it was, I was still doing a little bit of reverse engineering. I mean, like I had an IDA license back at the university, but I didn't really know what I was doing. Like I was not a reverse engineer. I was an incident responder who would occasionally pop it open to look at a particular interesting sample. And you know, so it really turned into something I spent a lot more time with. I actually wrote a couple of like kind of internal training manuals and books on disassembly and reverse engineering, and kind of, as long as I was just a few chapters ahead of students, right? So it was very much a figure it out as you go, fake it till you make it.
I think that's the secret to academic success if you're on the teaching side, is
right. You've been there, right? You've done that. You've been
you
an
just have to be
instructor.
one class ahead.
Yeah. And you learn a ton, right? You learn just by teaching it. You get asked a lot of questions, and being willing to be like, I don't know, but I'll find out and go figure it out. And I had a lot of smart coworkers. I can always, that's my other key life lesson, was always work with smart people, right? You want to be not the smartest person in the room. So I would always have somebody else I could learn from, and if I didn't know the answer, I would get it solved. So that was sort of fun again, and it played a lot of capture the flag during that period too. So continued to kind of play. Ended up playing at DEF CON for like almost a decade straight. Won 3 years, and yeah, have been involved in one way or the other for a lot since then, as well. But it's, got super hard, and so was doing, CTF for fun and kind of public things I could talk about. Had, doing work for a defense contractor, doing stuff in SCIFs, and then kind of wanted to move more into kind of commercial work. And for our capture the flag team, we had been working on this tool, Binary Ninja, and so it was a CTF tool. It was originally developed. There wasn't actually an original. It's still on GitHub. Actually, it's an open source Python version that had the name and some of the same kind of ideas, but a totally different code base. Like we rewrote it in C++ from scratch when we started Vector35. So it was like myself and Peter and Rusty, three of us that were there together at the defense contractor. We're like, all right, we're gonna we're going to go do this binary ninja thing. We think that there's been some stagnation in the market, and we can shake things up a little bit. Let's try to kind of have an impact and do some things differently. And it just seemed like fun. So that was kind of the impetus for starting Vector. So Vector 35 is the company name. We were all 35 years old in 2015, and so it was 35 was the number, and Vector it just seemed like a nice word. It kind of had like a little video game, vector graphics, vector art, kind of vibe to it, and just threw it together. But then Binary Ninja was always going to be the name of the product, and that's really the main focus of the company. All of the work we do is really centered around how do we make reverse engineering tooling better? How do we push the state of the art and improve that? So that's the kind of the short pitch of sort of how we got here.
So what was out there at the time then for primary RE tools? Obviously, IDA's been around with
Yeah.
X-rays for quite some time.
Yep.
But the 90s, I can't remember the exact history, but early 90s, I believe.
They are 32 years, 33 years now, something like that. Yeah, it's been a while.
Okay. What else was there? Anything that's persisted to today?
So, I mean, I had access to, so working at a government contractor and doing like kind of cleared work at the time, I actually had Ghidra. We didn't use it, but we had like a classified version of it. There's no secret there. Like, it's well known that it existed inside the NSA prior to
Right.
its public release. But I just hadn't really tried it. And we had kind of heard rumors like, oh yeah, it's going to get released. We're working on it. We're going to get it released. And so it was like, yeah, sure. Because we've been hearing it for so long that it seemed like it was like, but even when we were there, we primarily just used IDA. So that was just the tool of choice that we used. Hopper actually came out, I think, a little bit before Binary Ninja. I believe it was public and out there around that time too, which is super impressive because that's a one-man show. He's just one guy. He had his PhD thesis, and there was a time there where it had the best Swift Objective-C, or actually not Swift, I think, just Objective-C decompilation in particular on Mac OS and iOS. I think since then some other tooling is kind of surpassed it, but for a while there that was the tool of choice for sure. And I don't remember if Jeb was. I don't think Jeb was. I think that was a little bit after, but it may have been around the same time. So there's a couple of things that kind of started. There was Realize. I think Stephen Fewer had a tool, but that may have been a little bit after, kind of around that. There was a couple people who, in hindsight, were starting it, but I think we got a little bit more traction, grew a little bit more quickly, and we're kind of able to get the product a little bit more mature because it takes so much work to build. It's a really terrible business to be in, honestly, because it's like, you see like these web apps, these software as a service things selling for $100 a month or whatever they're charging, and it's like it's a weekend project. You could build that in. You can ask ChatGPT to write that tomorrow. And we had to spend 30 person years building a decompiler technology that was actually going to be impactful or to sort of stand up. And then halfway through that journey, so about 5 years ago now, for its Ghidra was actually released as open source. And so that kind of came out and has definitely mixed things up and made life a little bit more complicated for us.
Yeah, I would imagine so. I was teaching at a university during the 2000 teens for most of that decade, and we were a CA, a Center of Academic Excellence. So a lot of our students, well, I shouldn't say a lot, but we had a fair amount that would go every summer and intern at the agency.
Yeah.
And
Or like SFS, Scholarship for Service. Students go through there too. Yeah.
A lot of that. And so I heard rumors for quite a while about Ghidra or a tool that wasn't known as at Ghidra at the time that obviously became Ghidra.
Yeah.
But never knew for sure if that was going to launch or if students were just coming back with stories. I wasn't really sure. So it certainly has changed a lot of things, and I suppose it's good in some regards and probably very frustrating or challenging in others.
As a competitor, there absolutely are. Competing with the U.S. government, who's releasing a product for free and doing bug fixes and maintenance for free, can be a little frustrating, right? That's not necessarily my first pick, but there are definitely some positive aspects to it for sure. So
yeah. So 2016 then is when you launched Binary Ninja, July?
Yep. Yeah, it was about a year after we started the company. I'm embarrassed that we even sold it back then. I mean, I look back just at the product maturity and I'm like, how did people give us money? Now, to be fair, it was a lot cheaper. We had significantly lower price point. And it lacked a lot of stuff, but it already had a lot of the ingredients that we sort of knew were going to be important to our eventual success. Like we from the beginning, we knew that we wanted to like eventually have a collaboration server. We had seen just the attempts to get collaboration kind of
Mm-hmm.
added on to IDA over the years. At one point, I tracked like 14 different open source projects that were trying to like,
Yeah,
there
sure.
was collaborate, been, there's been so many different like these plugins over the years that tried to do collaborative reverse engineering. We felt like, okay, that's gonna be one thing we got to design from the beginning. We knew like from an API perspective, we were like, we want to build something that's gonna be the best at automation. We want to build a really good API and then a good UI and well design. But like, so there are already a couple pieces there that I think that we had at the beginning, and it's fun to kind of see them sort of really come into their own now and be like, yeah, like actually, I think we made some pretty good choices. I think we made a lot of mistakes along the way in terms of like prioritization, like what we did when, like, oh, we should have done that earlier and that later, and those little things like that. But the overall arc of like this is where we want to take the product, I think uh, was spot on and kind of has seen us through to sort of where we're at now. So the API, the UI being separate from the API, it's like one consistent API. Like IDA has always had. Like IDA Python was not even originally, an IDA thing. It was a third party that implemented it, then they integrated it. Whereas we designed our APIs from the beginning to be like first party and the same ones. We don't have like a private API. Like there's not like APIs that only Vector 35 can use these. So we just certain like philosophical things that I think have kind of borne out well.
How did you go from like knowing that you were having this internal tool for your CTF and your experience working in the gov private sector to making that decision that yes, this is something that we can build and launch a business off of?
Yeah, that was kind of unique because it was all actually about Cyber Grand Challenge. So the DARPA project that was like basically, can you make an automated system to play CTF, right? Can you build like the joke was sort of like if you wanted to be a program manager at DARPA, you would go there and they'd be like, "What are you interested? Okay, can a robot do that? Can we automate it? Like, can we make it fully autonomous? Driving? Ah, can a robot do that? And so drones, like all these things that they were the ones that originated like these autonomous aspects of. And so CGC was started by Mike Walker. In fact, actually, Mike Walker um, became a program manager at DARPA because of a talk that four of us gave at DARPA a while earlier, where all of us that had played on this capture the flag team together put together like a presentation. And at the time, we were working for the defense contractor who was like, "Yeah, go spend the time to make this talk really good because it just makes us look smart and good. So like you should just." So like literally, it was great. They paid for us to just really put a lot of work into the visualizations, into the data that we gathered. We had just a lot of really neat kind of like storytelling elements, and it was just really I love being super technical, and then I love communicating those technical things very visually and accurately. And so it was really fun to do some of that stuff. And so that turned into a talk that we kind of went all throughout like a lot of places in the government and just talked about like, hey, like the government does sort of cyber exercises wrong. Like that was the sort of premise. Where like instead of having like all red team or all blue team, you should have like in the real world, you have both a red and a blue and they work together. And then maybe another country is an adversary and they have a red and a blue and they work together. I mean, presumably they work together. If they don't, like there's problems. And that was kind of part of the point is that when you have like your offense and your defense and they're not aligned, if you don't have like an equities process that says like, oh, offense, that bug is too good, we're going to give it to defense and get it patched, right? Like that's a thing that's important. And like, does exist. There's been a lot of public talk about that lately, or in the last year's post node in particular. But so like we had these lessons learned from playing capture the flag. We're like, look, this is a little mini cyber war. Like this is a literally a sort of simulation of like what a cyber war would look like. There's a lot of interesting lessons. You, the government, should take notice and should change. They do things like CCDC, which is a pure defensive competition for students. As a instructor, I'm sure you're familiar
Yep.
with that.
Yeah.
There's also like the CDX, which is like basically the military academy is equivalent to the same thing. I think it's called CDX. I forget the acronym. But they do an event, and I had a chance to check it out a couple years. And again, it was like, well, that's great, but like you should be teaching these people to do both the offense and the defense. Don't just bring in the NSA Red Team to beat up on cadets. Like you should actually like let them do offense as well too and learn both sides of it, and it makes a better model for the stuff. So it was a super fun talk. We put a lot of work into it. And that's what turned into Mike going to DARPA and then being like, okay, fine, can you make a robot to do it? And so that was the Cyber Grand Challenge, was build a big spectacle, but also build this event. And so it's like Mike went there, had been working on the program for a while. Peter and myself, two of the co-founders, we were living in England at the time. So we were over helping a different part of our company essentially kind of spin up a new group for the British government. At least that was that was the idea, is that they would spin up this group of like hackers. So we were sort of known as like the troublemaker hacker types that got stuff done. And so they're like, oh, you should come and teach us how to do it. So we went to England and we're there for a while. I got to go walk around the donut in Cheltenham, which is very, very cool. It was fun to visit. It was not a fun place to work because it's like super noisy. They literally had to like hang banners just to like break up the sound, because it's
really?
it's like a giant, it's shaped like Apple's donut sphere ring or whatever, but like it's all open floor plan. Like every bit of it's massive open floor plan with like offices, like a couple like offices around the very outside edge. And so like you go in there and it was just very noisy. So, and they also like they had they basically did a hot disk environment where you would stay a week or something in one place, and then you had to move. So anyway, I'm glad I got to visit, but it would not be my preferred place to work full time. But a lot of really, really smart people, really cool stuff. And so it was fun to kind of be there. So it was also, sort of like the impetus then for starting Vector 35 was we come back and we're not really involved in any projects or programs. It was sort of a good time to leave. It's like, well, if we're going to leave, like now's a good time to do it. And we all three of us, Peter and Rusty and I, had been at a small company that was like SI Govs, was like the little company that got bought out. And so the company got bigger and bigger and bigger over the years. And so it's like, well, now might be the time to kind of do our thing. And then Cyber Grand Challenge comes along, and they basically were like, hey, if y'all could leave Raytheon, that'd be great, because Raytheon was a participant in Cyber Grand Challenge and couldn't be a subcontractor to help run the game. But they're like, we really want you guys to help us on the CTF side of things, because we had like real world experience. We had a lot of capture the flag experience. We even had some game and video game 3D programming experience. And so they're like, we're trying to build this visualization framework. And so our first contract as Vector 35 was helping to build the visuals for that event. And so they already had so they had originally put together the program, and they'd hired a game company. Oh shoot, I forget the name of the company. It's been too long. In fact, actually, I think the company itself is not around under that name anymore. But they were a smaller game company from Oakland. Had a couple of like industry folks who've been around for a while in the game company, and some good developers, but they didn't know CTF at all, or binary analysis, or reverse engineering. And so they were trying to build like 3D stuff in Unity without knowing at all what they were talking to and how it would work. And so we basically kind of helped translate what was happening in this competition into things that they could visualize and help design things. Like one of my sort of favorite contributions was I came up with the idea that we ended up calling the filament viewer, or the trace viewer, but it was essentially like trace program execution. So literally just look at instruction pointer like over time. We ended up adding more things eventually, but then you want to map that into like a Hilbert curve. So take all of the address space that your program ever executes, and then map that into a 2D plane. And like the whole point about a Hilbert curve, Mike Walker had what was it? It's a space saving packing mechanism whereby locality is preserved, was like the fancy way that he would put it. And I was like, yeah, it just means that like if two addresses were close in the the linear space, they'll be close in the 2D plane, right? So like if they're close, they're close. And so at any point, if you made a short jump inside the same function, or if all the code in a function was together, it would look like a little bundle of stuff together in the 2D plane. And then, if it was a jump to another function, you would see a big old like leap over to some other piece of code. And then you would extrude this like almost like a 3D printer into the third dimension. And now you get this like little squiggle over time. And so you would like run the programs in CGC, and you could look at what the program was doing. And the neat part about that was, you could, like, for example, when one of the teams patched a binary and they added a generic memory safety function. So all the function would do is validate, are you trying to read and write um, a valid piece of memory? It didn't even, it was just trying to prevent the program from crashing. It didn't even prevent like an exploit into a valid piece of memory, but it would prevent a program from crashing, because that was one of the ways as an attacker you could score points, is just by crashing the program. And so they were trying to generically detect that. Now it slowed it down a bunch, right? Because like every potentially unsafe read, they would call this thing, they would check it, and then they would return cleanly and like exit. So like it was much slower, but you could see it. Like you could see like the original like program would like do this little squiggles, and then you would see like the new one, and it would be like 5 times as long, and the squiggles would kind of be the same shape but like spread out. And now there was this new like chunk of code that was being run constantly, like real separate from all the rest of the code. And you're like, oh, I can look right there. Like I could describe what had happened in the transformation of this program just by looking at the shape of this kind of squiggle. So anyway, sorry, I get really excited about this stuff because it's just super kind of fun. And ironically, we don't do a whole lot of visualization stuff with Binary Ninja. It was something we kind of did on the side, just for CGC. But I think there's a lot of really interesting like analysis techniques that are fun to apply. It can be hard because a lot of the time you come up with some cool visualization, and it's like, yeah, but a table of numbers is actually just as good. Like there are certain things where like you want it to be cool and it looks nice, but it doesn't actually provide value. But I think there's also some where like it's legitimately um, to like those transformations of what teams were doing to patch functions and being able to look at a trace, and you could tell like what was happening. We'd add other things. We added syscalls and stack reads and writes and a few other things to the visualization. We annotated in different ways, and so it kind of got a little more complicated. But like at its base, you could just sort of tell what was happening by like the shape, or if it got stretched, or if it like got totally rewritten. So I thought that was really cool. So anyway, that was our first. I kind of like paid the bills basically while we started rewriting Binary Ninja and getting into something that as again in July, we had the first version. I think we sold the commercial version first. We announced it at DEF CON that year, and then a few months later we had the non-commercial version, and then like a year later we added our new level of IL, our medium level IL, which again, like the first version was basically just a disassembler. It was no real decompilation, and so we started adding on to our stack of ILs, which we now have notoriously like 9 of or something, 11. I don't know. We have a bunch kind of behind the scenes, but they're really useful. And it's kind of something that we do differently too than other tooling. So anyway, long story about the start of the company.
Yeah. Well, that's really cool. And the visualization thing is neat. I don't know how time travel debugging has eluded me all these years, but I've recently gotten into using that on a more consistent basis. And something like what you just described, I think could potentially be really helpful, because now you have a trace of execution, and I'm still kind of just zipping through it, trying to do my normal analysis, except I can go backwards. And I'm sure there's more to it than what I'm leveraging. So I'm still just kind of dabbling in it when I have time. But what you described, I mean, something like that, I would think would help tremendously, because now I have this whole execution that I can experiment with and visualize and see.
One of the things we did actually with CGC was we actually integrated Binary Ninja into that visualizer. So you could actually drag the cursor to a particular point, and it would synchronize Binary Ninja, open another window to that same location in the binary. So you could very quickly look at the code that was executing. There was like a little preview that showed like a snippet of disassembly in the bottom of like the Unity kind of environment as well. But like, just being able to like quickly be like, oh, okay, this is the new code that got added. Click, and then just go over and binge it and see the whole function. Be like, oh, this is a generic memory safety check. They're using this other syscall to probe for the fact that memory is readable or writable without triggering an exception and then returning true or false or exiting cleanly. Like you could just get that kind of understanding. So it was super useful. As an aside, we actually did have access to a time travel debugger prior to anything sort of public at the time back there as well. So Rusty, I mentioned there's 3 of us co-founders. It has long been ahead of the game as a very, very good developer. And he built a whole system emulator. And thankfully, the place we used to work, this would be a trade secret, but they published an article that they swore they were never going to publish and put it on the internet. I'm like, okay, good. Now I can talk about it because y'all released it. And so there was a piece of tech he built, goodness, 17 years ago, that he first built it, and it was a whole system reversible debugger, but not just a TTD, right? Because TTD, a lot of them are pure static traces that you can kind of look over, but this was actually like, no kidding, you could rewind, go live, and do something different. Like it was actually a reversible debugger, which was really cool. And it'll let you do a lot of neat stuff with like scalable fuzzing, which I'll send you a link to the the article that they published that they put out there. But that was a cool bit of tech.
Well, and I'll make sure to add it to the description here in the podcast as well. So
actually, ironically, I think was it attrition.org? Somebody randomly mirrored it too, which was good. Actually, I have the archive.org link too, which is really important because I want proof that I'm not releasing trade secrets from the company. Like, no, y'all did this. It was on your website. They had like so the company was Raytheon, and they had a magazine called Raytheon Today, which they used to just put in their lounges. And they're like, no, it's an internal company publication only. When we wrote up a description of this tooling, and we were all concerned, like, oh, but this is our like special secret reversible debugger. Like, no, it's fine. It's never going to go online. And then, years later, I look and sure enough, like I get like a Google alert for my name. So because I happened to write the article at the time, and then it like I was like, why is my name showing up on the website now? Because they published that article. And I was like, sweet, I can talk about it. So there you go. I'll put a link to that.
So, I brought up that I was, I got into reversing. I don't know. It was more of a kind of a strange mid-career or early career pivot for me. I found myself teaching, and I think what first really brought BN onto my radar was that there was the free edition, because I had a room full of students, and it was hard. It was kind of hard to use IDA, we couldn't get licenses for it. How do those decisions to create, and build the community, how do you make those? How do you continue to like evaluate the health of that decision and how it's helping you grow the product and the community, and then maybe even drive your development? I've been involved in some really healthy open source projects, and they seem to have at the center of their success a healthy community. Maybe not a large community, but a healthy, engaged, active community.
Yeah, somebody asked me recently. They were specifically talking about our community, and they're like, "How did you kind of curate the sort of like healthy, positive community that we've got so far?" We have, for example, a really active Slack, that has you're on it, you're aware of it, but it like it has a lot of people on it, and it's a good community. It's not like we specifically wrote out a bunch of community guidelines and heavily police it. I think we just sort of try our best to set a good example and model it. And we have very occasionally had to actually like police it or like enforce good behavior. But really, I think just sort of demonstrating, kind of golden rule of like let's treat each other the way that we want to be treated, and it has resulted in that. It wasn't. It's funny because so we at the beginning, we have a lot of sort of like values as a company. We really are very transparent. Like we're very public about how we do things. We use GitHub for all of our issues. Huge chunks of the product are actually open source. Like by lines of code, a large percentage of the product is actually released as open source modules. And like if we could get away with making the whole thing open source, I think we would. I just don't think the funding model would work for us in this like, size of our community. We look at like a Red Hat or whatever, and where maybe the only 5% of the customers or 1% of the customers actually pay for support, but those do pay so much that it covers the whole thing. And I don't think, especially when we started, that would have been a viable model for us. And so we kind of considered it and rejected it. But actually, the funny thing is we got accused of ripping off open source because someone's like, how dare you rewrite as a closed source tool this other open source thing. And we were like, okay, number one, we wrote the other open source thing. That was us. It's the same tool, the same people. Two, like, what do you mean? How are you getting to demand what we do with our license? Like, this is like, be glad that we're doing what we do. That was like totally random. We had to like add explicit notes to the other repo, but like, no, seriously, this is like a project. Like we could have just not released that at all if we really needed to. So partly there was a little bit of not shrewdness, but like calculatedness to the decision of like, we think that in particular, because IDA was so focused on the higher end of the market explicitly, that we had an opportunity to really take over at the student. We're like ours. We had sort of two-pronged attack, especially at the beginning. Like I said earlier, I'm embarrassed that we sold the product almost because at the beginning it lacked so many features. Relative to what it does now. But there were two things that we did. One is, we really wanted to make it accessible to students. We wanted to make it have both a non-commercial and kind of be more sort of welcoming in how we like engage with students. And then two, we had, like I said, our API and our focus. So what happened at the beginning is a lot of people were like, you're not replacing IDA for me in my sit down, decompile, manual reverse engineer. IDA's just too good. I'm too used to it. But dang it, if your scripting isn't so good that a lot of plugins and automation people would write on, they'd have a separate Binja license. They would write some plugins automation and then take those results back into IDA to do kind of their manual stuff. And so they were kind of using both. And so that was kind of our, so like our poison pill. We're like, okay, once we get you hooked on that, more and more as we remove the reasons that keep you from switching over, we can get some of like the higher, the experts kind of in the market, and then the lower end of the market with the students and hobbyists. Then we'll just sort of meet in the middle. We'll just keep building out features until we've kind of collapsed the middle. And that's, I talked earlier about sort of like, it feels like we've kind of executed on our vision. Like that's where it feels like we're at right now. I feel like we finally came together where we're now seeing a lot of people actually be like, yeah, you know what? Binja does everything I need and then some, and I like the interface better, and I like the API better, and I like the price better. Like, why not? And so we're starting to see people either have been resistant or known about us for a long time be like, okay, it's time. I'm making the switch. And so that feels really good, to have kind of like done that along the way. Back to like the community side though, it was kind of an accident. I wanted a Slack. So, people now are like, why don't you use Discord? I'm like, well, we probably would have if it wasn't so much worse 10 years ago than it is now. It lacked a lot of the features that I couldn't stand, the notification system and the red marking system. It was just a few things that like really weren't as good towards the beginning. But it was really nice building up just like this easy way for customers to talk to us and us to talk to them, and to have that as kind of a community. And then the other kind of half of it, I think, is just spend a lot of time in other Discords and in subreddits and on Twitter and in Mastodon, like all these different, trying to go where people are and just sort of listening to what they're saying. I think Hexrays has really a good product. It really is not a bad product. There's a reason that they existed for as long as they did, but they were never super active about listening to customers. They were kind of isolated and sort of did their own thing, and they kind of didn't really need to for a long time. And so it was a very conscious choice that we were like, no, we need to be really agile. We need to be really engaged. We need to really pay attention. We need to, be out there. So people like, I'll take my licks. Like there are times we get stuff wrong and I'm like, yeah, like we just don't do that right. Sorry, don't use us, or we're not good for that. Or like, we want to be very like upfront and out there. But like, if we don't talk to people, we don't know what they're having problems with to either one, fix them, or two, because like a lot of people, like you get some noisy people that will complain about your product to your face. Then you get a bunch of people who just quietly never use it because they hit some bug. And so it's a lot of work to really go after those people and really draw it out. And so I think I've learned a lot in the last decade. Because January will be 10 years of the company. So I guess it's only 9 or 8.5 years since the product launch. But in terms of like, I've learned a lot about getting information for people and asking better questions and listening and trying to like, just figure out like, what is it? Is it the cost? Is it this one feature? Is it they're just too much muscle memory and they're stuck and they're not going to move, and I can't sweat that. Like, what are the things that I can do to make the product better for people? And then what are the customers that I'm just not a fit for? And that's okay. Move on, go to the next person. That's been, I think, a large part of the learning process. And I do feel like we kind of got a little lucky with just the community. And a good example is I actually track. This is maybe a little vain. I track the number of plugins that people write for Binary Ninja and people have written for Hexrays, because they now have their public list of plugins in their sort of plugin database. And we've got our plugin managers in the product. It's in the UI. You can one-click install. In fact, literally just today, we pushed a release where now we can start adding native plugins to it. They don't install yet. It's coming. It's underway. But like, it will make it easier for people to find like these really cool plugins that exist. And so there's more plugins in our plugin manager than there is in IDA's. And I think that's just because we've really, that focus on the API and the automation from the beginning, I think has helped. And our IL stack and some other unique APIs that we've done some things that make it more attractive for that. But also, we just actively engage the community a lot. We've tried to gather them. We've tried to collect them. And for a long time, in Hexrays, you just had to like know where to go. You had to be looking to try to find, there were, a couple of collections here and there, their yearly contest that they ran was a good place to go look for stuff, but there was no like central place. And so as a result, the plugins would bit rot a lot too, because they weren't as easy to, sort of like a catch-22. And so from the beginning, we really sought to gather them all up. And that's why I think we have like a bigger collection of actively maintained plugins. Even though, admittedly, their customer base is much larger than ours. There are far more people using IDA than there are using Binja right now. But we've got some rabid fans, and they're writing a lot of plugins, and I think that benefits the ecosystem.
You mentioned just the chore of finding plugins, and it seems like that's an issue with just reverse engineering in general, and maybe vulnerability research, and that
Yeah.
there's a lot of really talented people. There's a lot of really great material out there, whether it's a technical paper or a blog post or some random paragraph in a really
Hmm.
heavy text. You really got to work for finding that content, it seems like. And I don't know, is that changing? Tools like this that then become so centered around the user and the community. Do you see that as a step forward to make reversing just more accessible to to those not only that are doing it, but maybe aspiring to become more
That's
into
a
the
really
reverse
good
engineering?
question. Yeah, I think in some ways we've progressed. In some ways we've almost regressed. I would say, for example, the decline of blog culture has hurt us as a community. You have more like YouTube videos, you have more tweets, you have more, but there's not nearly as many long form technical writing happening in our community compared to say 10 years ago, right? So I think like that, for example, is one way that we're a little bit worse off. Vulnerability research in particular is weird, right? Because like you have uh, this sort of like strange incentives where depending on who you are and what you're doing, like you don't want to describe too much about what you did because you maybe want to find more bugs. And there's again different. There's a lot of different reasons that people find bugs, and so it depends on where you're at and what you're doing. Um, but so some of it is just that like that people don't want to talk about how they found stuff because they want to go do it again. They want to find more. They don't want you to find it before them. So this is that's kind of strange game theory. I think around that a little bit. But at the same time, I do think you still see a lot of talks at conferences and plugins being released and people sharing knowledge, um, and there will always be a little bit of asymmetry. You're never going to have the government contractors and government agencies fully talking about all the tooling that they're building, right? Like, this is just not reasonable, I think, to expect to have happen. Or threat actors, right? You're not going to have all the malware authors talking about publicly about this cool new malware technique that they developed, right? Like
Yeah, yeah,
that's one of the things I love about security is that how we are one of the very few domains with active adversaries. Like it just makes it so much more interesting. Like the fact that there
mhm,
is much of the time a thinking human being on the other end of your problem versus a mechanical engineer who's designing things for a bridge. And yes, you have to deal with humans doing stupid stuff or whatever, but you very rarely have to deal with an active malicious adversary. It's more about like natural, forces. Maybe I guess with
yeah,
terrorism,
yeah,
that's not entirely true, but anyway,
yeah,
we're sort of distinct, I think, in that in a large respect, and so it makes it both harder, but also more fun in a lot of ways that we have. Combine that, of course, it was just a very changing environment. Like the compilers in use today are very different from the compilers in use 20 years ago, and
mhm,
so decompiling code, for example, has changed a lot. You have to constantly be updating with the latest file format changes that Apple's doing, on Mako files, for example, or the shared cache or whatever it is, and also then new memory tagging extensions and new CPU extensions, and there's just a lot of stuff very actively changing. So like that's the sort of like just tech side, like tech in general changes a lot,
mhm.
but then also adversarial, right? So security in particular is just very dynamic. Like there's a lot of stuff changing um, over time.
A BN release, Binary Ninja releases, we're now several years into the product, major versions.
Hmm.
It seems like you're on a pretty, a pretty aggressive release schedule
Yeah,
and updates all the time. What's on the horizon? I see Sidekick is a thing
yeah,
now.
yeah.
We certainly have these large language models that are maybe changing the landscape. Can you tell us a
Yeah.
little bit about that and like what gets you excited in the future for not only binary ninja but just the art of reverse engineering maybe in general?
Yeah, I liken the change that's happening with LLMs and other machine learning algorithms in reverse engineering a little bit to like the start of the decompiler era, age. If you look back at early decompilers, um, they were wrong a lot. They were just straight up buggy. They would just miss vast pieces of code, and they would invert conditionals, and they would just do things, and you're like, seriously, like why am I even using this tool? Sometimes, and this was just sort of the state of the art back then, right? It took a bit, and so it's funny to me. There were really good reverse engineers who refused to use a decompiler because they kind of got burned, and they looked at the early stuff, and they were like, this is just not good. And nowadays, I think you'd be hard pressed to find somebody who only stares at disassembly, who doesn't use a decompiler. And that's just not done because you're wasting your time. The decompilers are good enough, and your human brain is slow enough that like you're foolish to ignore it. And I feel a lot like that's going to be the state of LLMs. And so maybe we can argue about a matter of degree. Where are we on that curve? Are we already far enough along that they should be actively used by a lot of people? Or are we still at the phase where it's very immature and they're hallucinating a lot and they're wrong a lot? And you should just ignore them. So I think we could reasonably disagree on there. But I think I feel pretty confident in my claim that like that's the shape of the situation, right? Like it's a similar thing that they're barring issues with like LLM models, that's redundant. Barring the issue of like LLMs tainting the public things, and so future LLMs maybe will be dumber than the current ones. I don't think that's likely, right? We generally are only getting better. So this is sort of the worst that LLMs are ever going to be right now. So I 100%, our belief, and even in the company, we have varying degrees on this. Right, there's some people who are much more the AI skeptic, and we have to constantly. They're great people to like run our changes and features and stuff by to make sure that they sort of can pass their skepticism. Then we have other people who are like AI are changing the world and we're all gonna be out of jobs within a year. Like this is an existential threat to our way of life, and we better be freaked out by it, right? And so I think anywhere in between. In our little company of less than 20 people, right? So there's a lot of variety of opinions here, but I think it's definitely going to change. Like it's absolutely going to change things. I think we're trying to do our best to adapt with it and to grow with it. We were very lucky that we had a lot of internal early research predating the sort of interest in LLMs, so that we were kind of ready when it sort of came out. Well, what we had to do though was about throw out half of them. So we had about like 6 different sort of features of what we were doing. We would recover stack structures. We would name variables. We always do different operations that we would do. And literally half of them were like, oh, nope, our models aren't like our stuff's worse than just throwing it into OpenAI. So like get rid of that and then back it with Anthropic or with OpenAI or with whatever, because their models were just so much better as soon as we sort of like came to this realization, oh, just make it bigger, like add more connections and add more inputs and let it crank longer. And it turns out they get really good. And so, for things like human language and natural language, for, like I said, very domain specific problems like recovering structures, I think concrete or semi-concrete or like tuned implementations and algorithms are still better and will probably remain so for a while. So like there's still room for research like that, but there is a lot of value in wiring in these other large models. So Sidekick is the name of our plugin that does a bunch of different stuff. It's not just the sort of like one trick pony that I think most LLM integrations right now, which are just like we took our output and we tossed it to the LM and we asked it a question, or we asked it to like rename everything or to summarize. And it's like, yeah, that's the thing LLMs can do, but like you can do more, both on like the UI and the integration. And so Sidekick is really where a lot of our interesting research is happening, and a lot of new things we're trying to. For example, we just even a few months or two ago, we had Sidekick 2.0, and it's a pretty big change in like how it works, because it now has a sort of like the phrase I use is multi model, not multimodal. Like that term gets used in the AI community because a multimodal, it's like text and images and video and audio, like it's doing other modes of operation. But multi-model is actually like we have like an orchestration model. We have a higher level model that then is tasking other models that are maybe better suited towards particular tasks. So maybe I've got one thing that I use for analyzing all of my decompiled code, but it's maybe my orchestration, for example, understands high level concepts and it's very expensive per token, but very good at like creating a task or a workflow or a plan, and then they can task other things, which then are maybe smarter about other different things. One of them writes good code. One of them, analyzes the result of decompilation and like answers questions, or you can integrate these things. Or maybe one's like using an LLM that's online, and one of them's using a local one, so I can preserve some of my privacy concerns, right? Like my query goes to the expensive online one, but the data doesn't. My program stays local. And so like there's a lot of really interesting things you can do with that. So like that was a relatively big change. I think we're still not done with Binja itself. Like it's not like we're like, all right, we're done. We solved all the RE problems. Let's move along. There's still so many things that we're working on. Just like kind of in the near term, we've got iOS support. Our iOS support in particular on like the shared cache and kernel cache is not great. Just has never been. Like, we've had a couple plugins, we've it's been high on the list. We've had a lot of customers be like, tell me when I can finally switch to you for iOS support, but like, you're not there yet. And we've been working kind of on a lot of like precursors to our internal analysis to add support in the way that we wanted to see it done. And it's taken us longer than I would have liked. But that's in fact, I'm supposed to see a demo of the latest version this week, so that's exciting. It's hopefully we're going to have some progress on that in the next release. One really interesting thing that we're doing next is Rusty has got a change landing on dev probably here this week, next week, soon, that will basically decompile to different languages. So decompilers have either been Java, .NET specific to an intermediate language and the decompiled like stack. It's just one language, one architecture, one virtual machine, whatever, or they go to C. That's it. We've never had anything in between, right? Like, that's been what decompilers have done for 30 years. And so we've long had this idea of like, well, yeah, but like, why can't we decompile to Rust, to Golang, to Objective-C, to whatever the language is? And there's a couple of different parts of doing that well. And there's still a lot of work to be done on it, but like, the system for doing it generically is about done, and we're gonna release it as a in the next release. So, one simple example that's kind of fun is one of the demos that we did with it's on our blog with Sidekick, was where we asked the plugin to find all of the places where there were string decryption algorithms in binary. We asked it to rewrite one of them in Python. We asked it to sort of run that across all the cross references, pass in all the encrypted values, give me all the decrypted ones, and it's like, so just as a human, you just ask it to like solve the problem for me, describe, and it would go out and do all these different things, and like, ta-da, like a little bit of tweaking along the way. You may not one shot it. You may have to clarify a little bit, but it worked really well. But that step there where it said convert this C to Python, LLMs are actually pretty good at that, which is nice. They're really good at translating from one language to another. But we actually don't even need that step anymore, because like, that's one of the modes we can just decompile to Python. And it doesn't always work. The semantics aren't always like one where you can map, or there are certain things that like native assembly can do that are hard to represent in Rust, for example, or certain other languages. And so there's going to be, it's not meant to be a perfect source recovery, tool, but the idea that there may be times where you want your output into a different format, like a Python or a Rust. And it's also like the foundation for us to say, okay, now we already have, for example, an Objective-C plugin that will rewrite the intermediate languages we have to take like message send calls, for example, where it is a text parameter, which is basically saying call this virtual method for this object in Objective-C. I don't even know the Objective-C language for it. I'm not our Objective-C person. But like, and it rewrites the IL, so it's not a call to Objective-C message send, but rather it's like call to this virtual method. And so you can clean it. It makes the decompilation significantly better. And like, we've been, the plugin's been there, and it's really nice. It uses the feature called workflows, which let you sort of get in there and change how our decompilation is happening in sort of any way you want. And but like, being able to like then turn that back into actual Objective-C notation now is the next step, right? So kind of integrating the three phases, like the internal loading debug metadata. Golang in particular is notorious for that. Like, the file format may have extra information, modifying how you do the decompilation, knowing language constructs and knowing language features, and then outputting it as that language. Like, those three steps combined give you an actual like ability to decompile to some of these languages. So that's really exciting. I think that's kind of new, and we'll see where it goes. Again, I said we're pretty transparent, so there's no real secrets. Like, that's what we're doing. It's pretty out there. And it will be a little bit before it's kind of working well, but I think that's going to be a fun adventure to see like, how far can we go on each of these? How good can we get for each of these like language specific decompilations, while still retaining our same API, our same automation, all the other good things that we do, the UI, like, reusing kind of a lot of the value that we get there, instead of having a tool specific for each language, which again, I don't think anybody's ever done really. Other than, like I said, Hopper was really focused on Objective-C decompilation as its primary kind of function. There tend not to be. It's only like for virtual machines like Java and .NET, for example, that you tend to see the kind of domain specific decompilation. So it'll be interesting to have like a generic decompilation framework that also has these language specific features. So yeah, that's fun. I'm geeked for that. I am looking forward to seeing where we go with that. probably some other ones if I think about it too. But there's a long list of little decompiler things that we need better support for, and a lot of little features and stuff that we're working on. But those are probably some of the bigger ones there.
Is there, like, so we've talked a little bit about future, we've talked a lot about history. Now in this whole roadmap, is there anything that was like surprisingly complex or difficult or time consuming that
Yeah.
you just, and I guess this could extend to community and business, but really around the development of creating a disassembler, decompiler, all of the different ILs that are supported, the BNIL, if I read
Yeah.
the docs
Yep.
correct.
Yeah, there are debates about how you pronounce that. Is it Benil or BNIL? I tend to go BNIL because Benil sounds like a gas medicine or something. But
Yeah, I guess a little bit. Yeah,
BNX or Benil. But
yeah, I'm always very literal with my acronyms until
until
I
told
realize
otherwise. Yeah.
I don't have to be. So
Yeah. No, that one I think I say BNIL. Yeah, so BNIL is our sort of family of intermediate languages. Ironically, a lot of the things that you might expect to be hard sort of weren't. And I think that really a lot of that's attributed to Rusty being a really good developer and software architect and designer, and not just a good developer, but able to really understand the problem well enough that the design is going to scale and it's going to last. And I mean, there are pieces that we've either re-implemented or built. Then we're like, yeah, okay, we're going to go back and we're going to revisit our forward type propagation because it's there and it works, but it could be better. Or there's always things that you could do better if you had more time. Um, but I think for the most part, a lot of the things you think would be hard weren't. I mean, in particular, going from medium level IL to high level IL, which was really funny to us because we went to high level IL and we're like, that's it. We got our full decompiler. This is our decompiler. But until we did pseudo C, until we like added semicolons and braces, and it was a little more than that, but not much more than that. Until we did those things, there were people who didn't realize we had a decompiler. And so part of that is on us for communicating it poorly and
sure,
for like not,
yeah,
like doing a good job. But there were people like, oh, Benja has a decompiler finally. Fantastic. It looks great. And we're like, we've had it a year ago. Like, what are you talking about? So, but that is a good point too, that, like I said, I don't blame our customers for not knowing that. I blame us for being bad at communicating it, right? Like an engineer, sometimes you think that, something is obvious when it's really not. And so you have to be much more explicit than you think you should be, about, you have to tell people like 5 times and then they'll hear it once, right? So some of that's on us for not communicating. We've definitely tried to do a better job about communicating things. We still, we don't have a full-time marketing person, Twitter person. It's me, and when I remember to do it, and we try to get better at that. Because yeah, if you build a feature and nobody knows about it, like, what difference does it make? It really is important to communicate and to do a lot of really good documentation, to write blog posts, and to do these things, to teach people how to find it. There's way too much sort of lore and like little unknown secrets. I remember somebody told me once, like the insert key in IDA in this one particular menu or dialogue that I don't remember which dialogue it was. It's this really subtle behavior where there's a really cool feature and you would never know it's there if you're on a Mac because you don't have an insert key. You literally, like, right? Like if you don't have an external keyboard and you didn't know to hit it, like you'd never, and it's like powerful and there's no menu, there's no button, it's no right click, it's the insert key. And so, like, there's a lot of things like that where if we build a cool feature but we don't tell people how to do it, if we don't show them, if we don't give the good examples, so we've worked, actually it's been surprisingly hard to get our documentation in the state where, um, I thought we had good docs at the beginning and people kept saying like, no, your docs are crap. And I'm like, well, like, why? How? I just didn't get it for a long time. And so I think we've finally started to make a lot of the changes. We still have some improvements to go, but we've really we have like a cookbook section and like an overall concept section. We've added like some of the pieces that really help bring it together. It's not just API reference, but it's a lot of the other pieces and really helping people understand the concepts. That's been something that was harder. We spent way too much time building extensible UI plugins. Like Rusty took 6 months to let you write a pluggable UI system where anyone could write a UI plugin and tie it in. And that was completely unnecessary, at least at that point of the product. We should have, for example, done pseudo C or high level IL and not done this UI plugin stuff. That didn't matter nearly as much as we thought it did. So we definitely have learned, sort of in hindsight, we were like, oof, that was we should have done that way earlier, that like way later. Like that was a mistake. That's one of the most notable ones that we had, is how much time we took. Like, because we think about things in terms of like, what could Rusty have done with 3 months? What could Rusty have done with 6 months? Right? What could Rusty built in like 1 month, not even 2 weeks, our C++ inheritance type system, which works really, really well. Like, it is actually fantastic and supports like multiple inheritance, and the way that it integrates in the UI is just beautiful. Like, it is, I think the best. We don't have necessarily there's like some features like in the latest C++ and IDA 9 that's really good for like exception handling and stuff that Rolls worked on. It's fantastic. Like, that's a way better feature than we have. But our core like type system support for like inheritance, for example, I think is superior to anything else out there. And it was like 2 weeks of Rusty time. It didn't take that much time. So, man, 6 months that we blew letting him make extensible UIs that there's, there's like a dozen plugins that use heavily. Maybe we could have gotten away with a little bit less. So that's definitely one that I think we wasted time on. Yeah. The other thing is that I think that pricing a product is super hard. It's really easy. So everybody making fun of Hextras this week or angry at them for their subscription notice, be gentle. Like, it's real rough. It's really tough to like to understand pricing, to get what's fair value, what's the like, if I could charge people only what they could pay and what the value was to them, that'd be great, right? Like, I'd love to be able to make it cheaper for somebody. And this is why they do, like, companies will try to like price it cheaper in certain countries around the world to try to like, but then you get people gaming that. Like, it's a really hard thing to do. It's really, really difficult to figure out what's the right amount. And that's been one of our biggest struggles of like, when do we raise the price? By how much do we raise the price? Do we raise the price? Do we go cheaper? Do we add discounts? Do we like, all of that side of things has been, I think, a challenge, even so far as like the different choices, the different like editions of the product. We just launched a new Ultimate one that has a couple of new architectures, and that was kind of a big choice for us, because from the beginning, one of our big selling points was all of our architectures were available in every version of the product. Like, we had no architectures. It was part of our selling point over IDA. Is like, we don't nickel and dime you for every single variant of every architecture. And it's one of the things that makes us so much of a better value. But then we were like, well, we've got customers asking us to write support for C-Sky, which I had literally never heard of, or Nanomips, or Tricore, some of these very kind of esoteric things. And we're like, the only way this makes sense is if we price this separately and differently. Like, it's either we don't do it at all, or we do it at a new price point. And that was kind of the only way that it makes sense. And so I felt bad, like, because we had always like bragged about how like, oh, all the architectures included. And it's like, well, yeah, but we can't do it for some of these really weird esoteric niche things. Like, yes, all of our common ones we want to make available to everybody, but some of these, it's not worth the 3 months of development time, or 2 to 3 months of development time it's going to take to do a good job and well tested and build architecture support out. And so that was a little tough, trying to figure out kind of that balance, and where you price things and what features you put where. But I'm really happy. This is one thing that I think we did well at, that I'm happy about. From the beginning, I remember as a Hextras customer, like, things only ever got more expensive, and features never got added to the version that was the lower price point version. It was always trying to move you up the stream. And I totally get and understand why, as a business, that makes sense, because there's inflation, things get more expensive, and you kind of want to be, eventually you got to do something to kind of combat that, especially when you've been around for 30 years, right? So it's hard to know. It's really hard to know where to price things, at what point to put things. So anyways, long story to say, cut Hextras a little bit of slack. They're trying to figure things out. And I've seen a lot of angst about the subscription model. It's not something we're considering, but I would like to be able to consider it at some point. Hopefully we can do it in a way that everybody is okay with, if we ever do decide to do that. It's not on the immediate roadmap, but you never know when it's going to make sense. So it's tough. That's tough. Yeah, pricing is hard.
I'm sure. I can imagine it is difficult, and in some ways it's a lose-lose, because someone is always going to be change is going to upset someone. It's going to change how they're using or how they're working, so it is what it is, I guess. Great thing is, if you're interested in listening to the podcast, you want to check out Binary Ninja, you can go to binary.ninja. There is the web-based version.
Yep,
there is the free demo version. So you got a lot of great resources, a lot of capability at your fingertips to get started and compare it with other maybe RE tools that you're using now. Jordan, thank you so much for your time and for just spending. It's been about an hour, so we had a really great conversation.
Yeah.
Hopefully we can do this again in the near future.
Absolutely. Thanks, Josh.
All right.
Take care. Bye-bye.
And that's all for this episode of Behind the Binary. Thanks so much for tuning in. If you enjoyed the show, please consider subscribing and leaving a review. It really helps us to reach new listeners. Until then, stay curious and keep exploring.